Alright, we'll continue with limits today. Recall that we have calculated limits visually or graphically. And we've also tried direct substitution. Now, this works, the direct substitution method works for the most part, and I would always give it a try, but sometimes it is not the best way to go ahead. And so we'll do two examples where we have to use something else before we could apply direct substitution. So first, we will factor. Let me give you a motivating example here. Question is, find the limit as x approaches 1 of x squared minus 1 over x minus 1. And in the last lesson I distributed limit to everything, but this amounts, but to save writing space here, from now on you can just plug and chug wherever you see a 1 into the x. That amounts to being 1 squared minus 1 over 1 minus 1. Well, what's that? That's 0 over 0. Can we ever divide by 0? Nope. We can never divide by 0. So we need to think about something else. Think about something else. Alright. So one of the techniques is, can I simplify this fraction? And I gave it away. One way to see is, if you have a polynomial, can it be factored? And it turns out x squared minus 1 can be factored by the difference of two squares. I can rewrite x squared minus 1 over x minus 1 as x minus 1 times x plus 1 all over x minus 1. And guess what? We see that the x minus 1 cancels. So the real way to do this completely, let me start from the beginning, is as follows. Limit as x approaches 1 of x squared minus 1 over x plus 1 is the same thing as doing limit as x approaches 1 of x minus 1 times x plus 1 all over x minus 1. We notice that x minus 1's cancel. So we have limit as x approaches 1 of parentheses x plus 1. And now we can plug and chug 1 into the x. So we get 1 plus 1, which is equal to 2. And if you graph it, you will get precisely that answer. And because we're canceling out x minus 1, that means there is a hole at x equals 1 when you graph it. So we did do direct substitution here, but before that we had to check that we are not dividing by 0. Anyway, that's all for us today, and we'll do another interesting example in the next